Today we are going to be electrical engineers and build a cool buzzer game. The buzzer game will use electricity and implements the concept of a circuit to make a loud buzzing sound when we complete our circuit.
Now that we know what we're making, let's make sure all of our materials are ready. We should have 2 AA batteries, 1 AA battery holder, a 9-inch copper wire, 1 mini breadboard, 1 buzzer, 1 large paper clip, 3 large popsicle sticks, 2 small popsicle sticks, 4 male-pointed alligator clips. You know they're male-pointed if they have the point at the end. We should have 4 of them. 1 thumbtack, 2 double-sided tape squares, and 1 cardboard box from CCL with lid. Once you have all your materials ready, we can start building our project.
We will begin by grabbing our thumbtack and one of our large popsicle sticks. Carefully make a hole close to the top of your popsicle stick, about 1 inch from the top, and as middle aligned as you can. One way to make this easier is to first mark where you want to make the hole, then slowly apply force on the popsicle stick with the thumbtack while twisting it. Slowly apply force until it finally comes out the other side. Also make sure your fingers are not in the way on the other side. Once you have done that, I like to flip the popsicle stick around and twist the push pin in the hole once more to make sure that it will be easier to work with later. If the popsicle stick cracks while the students are pushing the thumbtack through, it should still be easy to use as long as the popsicle stick doesn't completely break. Now repeat this step with the other large popsicle stick. To make sure that the hole is positioned in a similar fashion, you can place the popsicle stick with the hole that you already made on top of the other popsicle stick as a guide to make the other hole. They don't have to be exactly aligned, but it's good to have them at about the same height. One thing you can note is to make sure not to make the hole too close to the top. This will prevent the popsicle stick from breaking while you're making the hole. Next, we're going to attach these popsicle sticks to our cardboard box. Grab 1 piece of double-sided tape and stick it toward the bottom of one of your popsicle sticks where there is no hole. With the longest side of the cardboard box facing you, attach the popsicle stick to either side of the cardboard box. Try to align the stick with the middle of the side as well as you can. And ensure that the stick is facing straight up. Once you have done 1 popsicle stick, you can do the same thing to the other side of your cardboard box using our other popsicle stick. Try to make the popsicle sticks as even as possible unless you want to make a more wacky obstacle course. Next, we're going to grab our copper wire. This is the part where you can get the most creative. Unravel your copper wire and start bending it to have as many loops and squiggly lines as you'd like. The more you have, the harder your game will be. You want to keep bending it around until it can comfortably fit between your 2 popsicle sticks. One thing to note here is that you want to make sure that both ends of your copper wire are level with each other and that they are straightened out. Once you're happy with your obstacle course, insert one end of your copper wire into the inner side of the hole in one of your popsicle sticks. Then grab the other end of your copper wire and insert it into the opposite popsicle stick, making sure that both ends of your copper wire are at least have at least half an inch of extra wire sticking out of the hole. This will make it easier when creating our circuit design. Now that we have our complete obstacle course, let's create the handle of our buzzer game. Grab your paper clip and straighten it out as best as you can. Next, using your finger, curl one of the ends to make a hook. If your finger isn't working, you can also try to use a pen or a pencil. Then, using one of our alligator clips, we're going to clasp it onto the end of our paper clip. The alligator clips sometimes come in a bundle, so you can grab one of the ends and gently peel it off of the rest of the clips. Open up the alligator clip and clip it onto the end of the paper clip that we did not make the hook on, and make sure that it is parallel with the paper clip and isn't at an angle to keep it from sliding off. Next, we will grab a small popsicle stick and we will secure our paper clip onto the popsicle stick using tape. Make sure that the hook is hanging out from the end of the popsicle stick. Once we have it positioned correctly, you can use some tape to secure it. Once you have it secure, that is our complete handle. Now that we've made our handle and our obstacle course, we'll move on to creating the actual circuit. Grab the breadboard and lay it in front of you horizontally. In other words, the breadboard will have more holes going from left to right compared to the amount of holes going from top to bottom. Keep in mind that we're going to be referring to the number of holes on the breadboard in rows and columns, with row 1, column 1 being in the top left, row 1, column 2 next to that, row 2, column 2 under that. Now that we know that, let's begin attaching components to the breadboard. Grab your small buzzer, which is this small black cylinder. Note that the buzzer has a piece of paper stuck on top. This muffles the sound, and we recommend telling your students to keep it on until their project is completed. Locate the positive side indicated by the longer leg and insert it into row 5, column 1. The negative or shorter leg should fit into row 5, column 4. Next, we're going to adjust the wires of our battery pack to ensure it's easier to connect to our breadboard. First, we'll focus on the red wire, the positive wire. And we're going to use 2 more of our alligator clips so you can peel those off. Clasp the open end of the alligator clip onto the silver part of the red wire and attach that into row 1, column 1. Do the same process with the black wire of our battery holder using the other alligator clip and insert the end into row 1, column 17, or the furthest right column. Now that we have our battery pack connected, ensure that the batteries are not yet inserted and that the switch on the battery holder is off to ensure safety. Grab the last alligator clip and clasp it onto one end of our obstacle course, where we left the wires sticking slightly out. You may need to bend the wires at the end to ensure that they don't slip out of the holes. Once you have the alligator clip on the obstacle course, you can insert the other end into row 1, column 4. Finally, we'll take the handle, which we previously created, and insert the end that is not clasped to the paper clip into row 5, column 17. Now we are ready to test our completed buzzer game. Now that we've finished building our buzzer game, we're ready to test. First, insert the batteries into the battery holder. Then we're ready to turn it on. You'll notice that nothing happens, but this is because we currently have an unclosed circuit. To close it, we need to make contact between our handle and the copper wire of our obstacle course. If everything is connected correctly, we should be able to hear our buzzer go off. At this point, give your students some time to play around with their own buzzer games, or even go around trying other students' creations. The goal of the buzzer game is to get from one end of your obstacle course to the other without touching the paper clip to the copper wire, similar to the way that operation works. One thing to note here is that most of the buzzers come with a sticker attached to the top. This will prevent it from being too loud, and the students can remove it once the class is over. In the case that the buzzer game is not working properly, there are a few steps that we can take to resolve this. First, switch the battery holder to the off position for safety, and check that the batteries are inserted properly, with the flat end of each battery touching the spring in the battery holder. Once fixed, you can try the buzzer game again. Another thing that you can test is checking that the alligator clips are placed in the correct orientation, and that they are touching the silver parts of the wires, not the protective coating. If this doesn't work, then you can also double check that each component is connected correctly in the breadboard in the correct position. And if all else fails, you can try replacing the batteries in the battery pack. Now that we're done testing, let's learn about how our buzzer game works. Our project works because we start with an open circuit that is only closed when our handle touches our copper wire. An open circuit is a path where electricity is prevented from flowing until it is closed. Think of it as a red traffic light. The electricity flowing through the circuit is unable to go through that light until it turns green, or in our case, when our handle touches our copper wire. Once we touch the handle to the copper wire, it completes the circuit, allowing the electricity to run through the circuit, run through the buzzer, causing our buzzer to go off. Otherwise, when we don't have our handle touching the copper wire, there is no electrical current running through the circuit because it's open, which is why our buzzer begins silent when we start our game. Some questions your students can think about to better understand the buzzer game are: how can we visually show that we've touched the copper wire? Can we make our obstacle course harder? Or what about making it easier? And can you think of any other games that can use the concepts that we learned about in this project?